Okay, hello, welcome back. It's been a little while since I've made a recording, but time to do another one. As you can see, this is going to go into the exam work-through section of the playlists. I'm going through today the GCSE Mathematics Practice Test, Set 1, Paper 2H, which is the second of the three. I will probably try and do a video for the other two at some point, but if you are working through revision at this stage, this is probably the paper you'll be concentrating on prior to working through some other past papers. If you're new to this channel, please do leave a like or subscribe. That would help me out a ton. And in case you're just new to the channel, what this is really just a chance for me to work through different exam schemes to help you with revision, really, for those of you working towards GCSE in the summer. Right, without further ado, let's crack on. This is number one. So you can see here it's talking about currency and exchange rates. Talking about this guy that has £600 and you're having to change it into rupees, and it's asking you to understand how much you would need to change in 2012 to match what you did in 2010. Now you can see that the pound has strengthened between 2010 and 2012. You are getting slightly more rupees for your pound, so you're expecting that it will be something cheaper than the £600 that you paid out originally. So that's a little bit of error checking to start with. Just make sure you take account of the fact that you are going to be expecting something less than 600. That said, it's a very simple calculation. You're just working your way through 600 times 67.1, which is this rate up here, times by the £600, and you will get, well, 40, sorry, it's not pounds, it's 40,260 Indian rupees. I'll just use an R there. And then you have to find out how many, I had to convert that back into pounds from this year. So you're just simply doing 40,260 divided by 82.5. You're allowed to use a calculator. And when you tap that in, you'll get £488, and very straightforward. That's the answer to this particular question. It's only worth 3 marks if you see down the bottom there, so not very many marks, but a good, nice introduction to a fairly easy problem. Strolling on into number 2, we're going to take a look at this one now. So this is about a party. Actually, I've seen this question answered pretty poorly, and matches a lot of questions that you get nowadays. There was one like it this year in 2019, if you're watching this in 2019, that was a little bit like this. So this is what this is as a lowest common multiple question. And a lot of people go for Venn diagrams and looking at lowest common multiples, and that's perfectly fine. But in this particular question, it might be slightly better to look for the sort of more traditional way of finding lowest common multiple. So you're trying to find lowest common multiple in this question between 12 and 8, because you're trying to find the same amount of cakes as sausage rolls. That's what it says there, same amount of cakes as sausage rolls. So we're going to list the first few multiples of 12. So 12, 24, 36, 48, 60, and 72, and 84, and so on. And again with 8, list out the first few multiples of 8. So 8, 16, 24, we've got 32, 40, 48, and then 56, and then 64, and then 70, 72, and then 80, excuse me. So we've got several multiples there. We've got 24 and 48 and 72 in our list there. But this is what I mean when I say it's kind of a lowest common multiple question, but with a bit of a difference, because the lowest common multiple wouldn't do it here, because if we chose 24, which is what the Venn diagram will get you, that's not going to be more than 60 sausage rolls. So we're looking for a multiple that's more than 60 sausage rolls. That's where the problem comes in about using Venn diagrams for this question. It's not quite suitable. So here it's going to be 72 cakes and 72 sausage rolls that we need to buy. And then you have to source back to the question and say, well, if I need 72 cakes, I need, well, how many boxes of cakes do I need? I'm going to need 6 boxes of cakes, so 6 lots of £2.50 is what I'm going to need. And again, if I need 72 sausage rolls, how many packets of sausage rolls? I'm going to need 9 of those, so 9 lots of £1.20, and then you're going to work those out and then add them up. This will give you 15, and 9 lots of £1.20 is going to give you £10.80, I think. Yep, £10.80. And then you're going to add those up to get £25.80. So I'm just writing that down there, £25.80, and that will get you quite a lot of marks for this question, 5 marks. So nice kind of bonus question there. This question, well, the minute you see it, you can see it's straightforward trig. In this case, Pythagoras. So you're looking for just a hypotenuse. So simply just you're looking for, well, of course we know BC squared is 6 squared plus 9 squared. So that's going to be 36 plus 81. 36 plus 81 is going to be 117. And so BC will be the square root of 117, which is going to be 10.8. And be sure to give it to 3 SFs there to make sure. So 10.8 centimetres to get it through to 3 SFs. Again, really straightforward at this stage. These questions are the ones that you really should be getting 100% on if you're aiming for the higher grades. So question 4. Our straight reaction to a correlation question will always be to try and draw a straight line of correlation. You don't always have to draw a line, just be aware that there's 3 types of situation you could have: positive correlation, negative correlation, or no correlation at all. Of course, in this example, we have got a negative correlation here. I'm going to draw my straight line to go as close to or as near to as many points as possible, really taking quite a lot of care to make sure that straight line maps to as many crosses as possible. And what type of correlation does this scatter graph show? Take a note of the amount of marks for this question. It's just 1 mark. If it's 2 marks, they'll require some sort of strength comment. So for example, strong negative correlation or strong positive correlation. Here it's negative because it's going downhill. So it is negative correlation. Don't write more than the question requires. You're only getting 1 mark. So negative correlation will get you the 1 mark. If you're getting 2 marks, strong negative would have been a way to get the 2 marks here. The second part of the question is just reading off from the graph. So it's asking about the speed of a car if it's going 0 to 60 in 11 seconds. So you just read up from the graph to 11. That's going to be around here. So I'm making that around sort of 120 or so, maybe 121, something like that. There'll be a range of answer that you can give, but here I think 121 miles per hour would be a straightforward calculation. It might be worth, if you have time at the end of the exam, to go back and draw the line that you used to read it off, so you can actually demonstrate to the examiner where you got it from. But to be honest, it's not absolutely essential. It's just something nice to do as a bonus if you have the time. Question 5 is a formation of equation question. So it's talking about these 3 car parks. It's really about just taking your time on these sorts of questions, just taking your time and making sure that you are identifying the 3 car parks carefully. So I'm going to use S, C and N for south, central and north. South car park has X spaces. The north car park has 48 more spaces than the south one, so that's 48 plus X, or X plus 48. And the central car park has 4 times as many spaces as south. This was the south. Oh, sorry, I've got a bit wrong there, haven't I? So this is X plus 48. And then the central car park, sorry, has 4 times as many spaces as south. Here is the south, so this is 4X here. So just making sure that you've got each particular section matching up with each 3 car parks. So just take that again. South is X, north is X plus 48, and central is 4 times as many as the south one. So that all checks out. It's asking for the total, so you add them all up. So X plus 4X plus X plus 48, you're adding them all up. And it's telling you that the total number of spaces in south and central is more than twice of more than twice the number of spaces in the north car park. So X plus 4X is more than twice. So I'm going to use the symbol more than here. More than twice the number in the north car park. So just let myself get my brain around that. So get myself sorted out there. So it's more than twice. So x plus 4x is more than twice of the ones in the north car park. You can multiply out the brackets to get you to x plus 96, and then this would be 5x, and then gathering together, 3x is more than 96, which means that x has to be more than 32. So the least possible spaces, which is what it's asking for, the least possible spaces has to be 33, because that's the number that's the next number on from 32. It can't be 32, it has to be the next one on from 32, the least number of spaces. So that's how you get to that particular answer quickly. As you can see, it's easy to make slips, but just make sure you compartmentalise your thinking, and you should be okay, and just double check as you're going along like I was doing, and hopefully those mistakes won't cost you too badly if you make sure you can correct them quickly. Question 6, again, it's a very trivial question. It's easy to make simple mistakes, so we'll take a bit more time on this one, make sure I get it right. So the perimeters of these two shapes are the same. Got rectangle and trapezium, so you're asking to understand what a perimeter is. So obviously it's distance around the outside. Don't mess it up with area, that's very common. So you're trying to understand how to work out the perimeter. So in the rectangle, it's 3x plus 4 plus 4x, and then plus another 3x plus 4 and another 4x. And if you add those all up, you will get 14x plus 8. And then on the trapezium side of things, you're going to have to add that and that and that and that. So x minus 3 plus 5x plus 7x minus 3 plus 5x. And again, if you add them all up, you get 10, 17, and you get 18x minus 6. So minus 3 there. So these two things are the same. So 14x plus 8 is equal to 18x minus 6. And again, you're going to have 8 plus 6 here to give you 14, and then 18 minus the 14 to give you 4x. That's going to give you 14 over 4, 7 over 2, 3.5 4x. It's then asking you to write down the length and the width of the rectangle. So the length of the rectangle would be 3 lots of that x plus 4. So 3 lots of that 3.5 plus 4. And then the width will be 4 lots of that 3.5. You can see from the work above, that's how it's going to work. So 14.5, and then 14, and then you fill those bits in. So 14.5, and then 14, and that will get you your very generous 6 marks. Question 7 is a tree diagram question. So you're working your way through with tree diagrams, making sure you've got yourself understanding where to go. It's a causation diagram, so when the damage is minor, the probability that an insurance claim is made is 0.22, so this is minor, so 0.22 goes in there. When the probability is severe, it's 0.74, so we're going to put 0.74 in there. Remember, these branches have to add to 1, that's the key thing you need to look for. So this is going to be 0.78, and then underneath here we're going to have 0.74, and then we're going to have 0.26. Okay, there we go. So we're then told in the question to complete the tree diagram, which we've done. It's asking to say if the probability the insurance claims for damage will be made is greater than 50%, the insurance company will increase their charges for insurance. Will the insurance company increase their charges? Well, the first thing you've got to say is either yes or no, but you've got to make sure you have the evidence to say yes or no. So you have to work out each individual understanding and see what's going on. So the chance of making a claim will be up here 0.55 followed by the 0.22. So that's 0.55 times 0.22. And then the other way of making a claim would be to do 0.45 and then 0.74. So 0.45 times 0.74. So you've got to add that all up and work out the total, and you will get, if you do it carefully, 0.2121 and 0.333, and that's going to be 0.454, and that is not more than 50%, because that is 45%. So if it's not more than 50%, then they're not going to increase their charges, so no, there'll be no increase. Not bigger, I'll just explain, not bigger than 50%. So you are just writing down that little statement there to say to the examiner, yes, I'm perfectly clear and happy that I know they're not going to be making any claims. Number 8. Number 8 is very straightforward. If you have been revising well, you'll recognise it as a linear simultaneous equation system. Very quite simple. We can do it just as it lies here. We just simply need to take one away from the other one to eliminate the x here because the coefficients are already the same. So 3 minus 6 is minus 3. 2y minus minus y is 3y, which makes y is minus 1. And that must mean that if y is minus 1, then x is 5. So it's very straightforward, but many a person would make mistakes with the signs and all sorts of things. So just be clear that you are understanding where this is all coming from. Of course, you get the 5 by substitution if you know you're taking away minus 1. So in other words, x plus 1 is 6. X must be 5. That's where that comes from. So you can test out the value in the first one to make sure it works. So, 5, take away 2, does that make 3? Yes, it does. So you are going to check that to make sure it definitely works. Question 9 is a very straightforward sort of fractional question. The clues are all there. So Colin gets 3/10, Dave and Emma get the rest, so they get 7/10 of the money. It's saying what's Dave's share, and they're sharing the ratio 3:2, so he's getting 2/5 of the remainder. 2/5 of the remainder, because you can see that the number here is 2, and if you total those up, that's 5. So it's 2/5 of 7/10. So 2/5 of 7/10 is simply the calculation you do. So 14 out of 50, and that is the share of the money that he will get. Now, the nth term of the sequence being n squared plus 4. It says the nth term of the sequence is always a prime number where n is an odd number, and Alex is wrong. Give an example to show that Alex is wrong. So you just try out a few options. It's really the way to go. Just try out a few different things and it will be fine. So if you try 1, for example, 1 squared plus 4 is 5, so that's prime. Try 3, so 3 squared plus 4, that's 9 plus 4, that's 13, so that's prime. You could try 5, so 5 squared plus 4 is 29, that's also prime. You could try 7, 7 squared, 49 plus 4 is 53, that's prime. Then you're trying 9, 9 squared is 81 plus 4 is 85. Oh, there you go. 9, n is 9, 81 plus 4 is 85. This is not prime. So there we go, there's the counter example. And that will always be the case, that if you show or go through a couple of options, you'll always find the counter example relatively quickly. So we're on to now where we're starting to get into the domain of questions that students aiming for the higher grades will want to be getting right. So the game is always to get the first 10 correct, and then as you're going through from the first 10 to try and get as many marks as you can from 11 onwards. So that's the really important thing about GCSE High. That's where your work is going to be if you want. So the 7s, 8s and 9s, that's where you're concentrating, is to try and get the first 10 or so questions correct. And if you want the high grades, then just try and pick off as many marks as you can from this way onwards. So from here on, we're pretty much talking about, the more complex topics, and you can see that they build the difficulty as they go. This particular question is a non-right-angled triangle. So it's a non-right-angled triangle, non-right-angled trigonometry. You're sort of thinking about working out the size of angle A. Size of angle A is here. So first of all, identifying that angle. We've got 3 sides and a missing angle. So this is going to be the cosine rule. So let's state the cosine rule first, but just to understand how the cosine rule looks with the numbers that we have. So 3.6 squared equals 1.8 squared plus 2.7 squared minus 2 lots of 1.8 times 2.7 cosine A, where A is what we need to work out. So this is just a squared equals b squared plus c squared minus 2bc cosine A, which you should hopefully know, and that is very straightforward to remember and should be something that you've got in your locker. 12.96 is what 3.6 squared is. This is 10.53 when you start to work out what's going on over here, and then 9.72 cosine A. and then you need to work out, rearrange it to get cosine A. So you would do 12.96 take away 10.53, which is 2.43, and then divided by minus 9.72, and that hopefully will give you a value that you can then test. Of course, filling that in the calculator is quite important, so you can do it simply as it's done. So you just do a shift cosine, so you get the cosine there, and then just put the fraction in that you've got here. So you would have 2.43, and then underneath you've got minus 9.72, and then close the brackets and then press the equal sign, and that should give you the answer, 104.5 to 1 dp. So 104.5 degrees, and that will be, that's the answer that you need. And it makes sense that it's more than 90, because you can see in a diagram, although it's not drawn to scale, that particular question, that answer should be more than 90, should make sense. Now, then it's asking you to work out the area of a triangle. Again, it's a non-right angled triangle. So the easiest way to think about area would be half AB sine C. So you're doing half lots of 1.8 times 2.7 times sine of the angle you just worked out. It's important that you use the very long decimal, 104.4775122, that you get up here. So I'm going to write that down here just to show you what you've got in the calculator. I've got it still here, that's how I know it's what it is. I've got it still there. So I'm going to write that down to show the examiner that's what I'm using. They're trying to tempt you to use the 104.5, and you'll get some error message, you'll get some carried error with that if you use the rounded number. So I'm going to use the original number, the 7.75, etc., because I don't want there to be any rounding error. So you're going to pop all that into the calculator. Very straightforward, and again you can use the calculator to help you. So I'm going to do sine of this, sine of the answer, that gets you that, and then you're going to do times 2.7 times 1.8, just working this out in my calculator here, and then divided by 2, and that should hopefully give you this, which is again to one decimal place, which is what the question's asking for, 2.4 centimeters squared. So let's just write that in there. So 2.4, and you get your 5 marks for that particular page. This question's now getting more difficult. So it's asking for a suitable degree of accuracy by considering bounds. When you get questions that ask you for a suitable degree of accuracy, the first thing you should be leading yourself to do is by looking at upper and lower bounds of each particular value that you've been given. But interpreting those upper and lower bounds of those individual things is quite important. So you do need to make sure that you've taken account of those things. So I'm going to start off by sketching down my what I call my D max, the maximum value that can be, my D minimum, my F max, and my F minimum. So I'm going to write those down. Now, if the D value has been rounded to 3 significant figures, we need 4 significant figures in my D max. So that's 190.54. And then D minimum would be 189.5. Again, 4 significant figures. If F has been rounded to 1 decimal place, I need 2 decimal places in my F max, 25.75. And I need my minimum, 25.65. Again, 2 decimal places. The C max, so the value for C, D divided by F, will be the topmost D divided by the minimum most F. So 190.5 divided by 25.65. And the C minimum for C, will be the smallest value for this, so 189.5, divided by the maximum value for that, 25.75. That's going to be my 2 corresponding values. When you do that, you get 7.426900584795, and tapping the buttons, you get 7.3592233 69, etc. Okay, and we want to look at where these agree to a suitable degree of accuracy. They're both 7, they're both 7.4, but they don't agree beyond there. So 7.4 is where they agree. So to a suitable degree of accuracy, the numbers both match to 7.4. So it's a very straightforward answer. That's how you do it. Make sure you're aware. Question 13 is a liquid and density question. Your paramount response to anything with compound measurements should be to try and draw the triangle that you've remembered for that particular compound measurement. So in this case, it will be the DMV triangle. And then you're going through just constructing what you've been given. So here is a mass, so 140. You've been given a density, so you're going to do mass divided by density to get the volume. So 140 divided by 0.7, that gives you 200. That's the volume for A. And then a similar way for the second one, so you've got 128 divided by 1.6, and that's going to give you 80 for the compound or liquid B. And then of course you need to combine their masses to get 280. So 280 combined volume, sorry. So that's combined volume. And then you've got their combined mass, which you can work out because their combined mass here was 268. So the combined density for liquid C will be the combined mass, so 140 plus 128, sorry, over that 280. So it's 268 divided by 280. And that is going to give you, when you do it, 0.957. Very straightforward, easy to do, but just remembering the key steps always, all the way through to remember your compound measurements. Question 14, you can see, is a functions question. As functions questions go, this is not that hard, and I would like to point out that this particular page is worth 9 marks. So you're cashing in a lot of marks for this particular question if you know what you're doing. So taking your time through this is important because it's worth the time. Now, for this one, first of all, we've got 2x plus 5. 2x plus 5 with f of 3, for example. We've got 2 3s are 6, 6 plus 5 is 11. So that's going to give you 11. The inverse function, to get an inverse function, you let y be 2x plus 5. You rearrange it to get the x as a subject to the formula. So then you can write down your function. So x minus 5 over 2 in this case. Very straightforward. G of minus 3, you can do minus 3 squared. So minus 3 squared is 9, positive 9. 9 minus 25 is minus 16. So again, trotting your way through. Now this one, g of f of x. So with functions, you've got to do always the f of x first, and then the resultant part of that you put into g. So up here we're going to put the resultant of my f function. So I'm going to have 2x plus 5 squared minus 25. So the f of x bit squared minus 25. That's what you're doing. You can multiply these brackets. So 4x squared plus 20x plus 25. And then minus this 25 that's left here. These two things will cancel, leaving you with 4x squared plus 20x. Lastly, it asks you to solve this. So you're going to do this by factorising. You can see they've got 4x as common, leaving you with x is 0 or minus 5 as my two roots. And you'll see that that particular section of questions is worth 5 marks. They're trying not to tell you this is worth the 2 and that's worth the 3, but this is worth 2 at least because you've got two roots here. So it's important to get them both. Okay, next question. This is a probability question, tree diagrams. So again, very good, well worth you knowing how tree diagrams work. How do we know it's a tree diagrams question? It's a limited set of options with a limited set of probabilities and possibilities. So it's suitable for a tree diagram question. Doesn't ask you to do a tree diagram question, but absolutely is suitable for that. You would make sure that you're drawing that three-way tree diagram question very, very carefully. So I'm going to sketch that really carefully now. So the three possibilities, orange, red, yellow. And again, we're going to have orange, red, yellow, orange, red, yellow, and then again, orange, red, and yellow. And then for each of these, we have different possibilities. Now it's asking you to see the probability that the sweets will not be the same colour. Now, if they're not going to be the same colour, then you've only got two options here. They're either not of the same colour or they are of the same colour. So actually, if you work out the ones that are of the same colour and take that probability away from 1, you will have your answer. So that's a simpler way of working this particular problem. So it saves you a bit of working out. So what you're going to try and do is work out the chances of getting an orange and an orange, a red and a red, a yellow and a yellow, adding them up and then taking that answer away from 1. It's conditional probability. You're going to eat the sweets, obviously, so you need to think about how you're going to work those out. So to get the orange ones, we've got 5 over 20. To get the red ones, we've got 7 over 20. To get the yellow ones, we've got 8 out of 20. Once you've eaten an orange, that's 4 out of 19. Once you've eaten a red, it's going to be 6 out of 19. Once you've eaten a yellow, it's going to be 7 out of 19. So these are the 3 branches that you're constructing, and then you're going to need to work out the probabilities of each particular option. So 5 over 20 times 4 over 19, or 7 over 20 times 6 over 19, or 8 out of 20 times 7 over 19. This is a chance of getting them both the same colour. So you work those all out. This is going to be 191 there, and that's going to be there. Just tapping the buttons of my calculator if you wonder what I'm making all these noises about. And you will get eventually 59 over 190. So this is all going to make 59 out of 190. We need the probability of them being different colour, so we're going to take that away from 1, and then you can see the answer is going to be 131 out of 190. So it's a straightforward get, but you've got to make sure that you've kept your work down to a minimum. Make sure you've got less room for error by cutting your work down and thinking through what you've got. Question 16 is an inverse proportion question. We're going to convert simply the first sentence into a mathematical sentence. So it's telling you about the fact that P is inversely proportional to the square of X. So this is the first response to that always. You've got to then figure out what this constant of proportionality is. You'll do that by subbing in values from the question. So P is 6 and K is 5. That means that K is going to be 150. And that must mean for the second part of the question that if we know the relationship between the two is 150 divided by x squared, 150 divided by 64 will give me my P, which when you work it out is 2.34. And that's a very simple, quick 3 marks. Question 17 is an interesting question. This I've tested with candidates and it does throw people off. So this is about scaling up things, enlargement by a scale factor, even though it doesn't actually look like that. It's talking about the larger rectangle being 3 times the dimensions of the smaller rectangle. So if you've got a rectangle here, you've got a larger one here, and what they're saying is it's the times by 3 is the scale factor to get from there to there. Now you will know from the work that you've done that your area scale factor, so the area scale factor to get from one to the other one, will be 3 squared, the length squared. And you've probably learned that at some point in the past. Why is area important? Because you're going to cover the area with this particular amount of soil. And it's saying if you need 180 in the smaller flower bed, how much do you need for the larger flower bed? So you just do 180, the amount of kilograms of soil you need for the smaller one, the area of the smaller one, in other words, times by 9 to get the amount of mass you need for the higher one. And again, if you work that through, you will get that very quickly. So 180 times 9, and that's going to give you 1620 kilograms here for your 2 marks. It's a fairly straightforward question, but does throw candidates, definitely. Now, question 18, it starts to get really hard at this stage. These last couple of questions are really quite difficult and are trying to sort out who the candidates are, that they're going to get 8s and 9s. So be aware of that when you're into the final 3. That's what you're talking about, 8s and 9s. I've done a whole playlist series on the final 3, so if you want to catch that, that's available on my channel. Do take a look at that. I'm going through all the final 3 questions for every single test since this particular specification started, so that's well worth catching if you are on the last few months of your revision. The first thing to worry about with frequency density diagrams is just what is the area of each of the individual bars, and that's how you would basically start this. You're going to start this by working through the area of each bars, but of course the problem is we don't have the scale on the side. Because we're asked about a median here, just reveal that, it doesn't actually matter what the scale on the side is. We can actually sort of construct that for ourselves. So I'm going to call each of these measurements just 1. And again, as long as you're consistent and you're careful, you can just label those what you want. And then we're going to work out the area constructed with these measurements on the side of each individual bar. This one you'll get is 19, because it's 2.5 times 7.6. This one's going to be 70.5, again 55 to 62.5 times by 9.4. This one's 28, so again 62.5, 67.5, and then times by 5.6 here, and then you've got finally 21. Okay, so all of those areas I've written in. When you add those all up, you're going to get a total. In this case, the total is 138.5. So we've got 138.5 cars in the system here. We've got to then work out where our median value will be. So our median value is going to be halfway through that set. So our 69.25th value, okay, halfway through. We want to work out what the 69.25th value is occurring. It's going to be somewhere in here, isn't it? Because we've got 70.5, 19 there. So the 60.25th value is going to be in here somewhere. We need to understand where. So we're going to have to work out where it ends. So we do 69.25 to take away the 19 that we got in our first box, and that gives us 50.25. We're now trying to find 50.25th of the way through this rectangle, wherever it is. So we need the height of the rectangle, which we know, 9.4. So I'm going to do 50.25 divided by 9.4. Okay, and that is going to give me a value. So I'm going to work that out on my calculator now. So 50.25 divided by 9.4. It's going to be something horrible, I think. So it's this very horrible number, 5.345. That is the distance through this particular bar it is. So it's 5.345 away from 55. So we need to add that to 55 to find out where it is. So we're going to add that to 55, and we're finding out where the value occurs. It occurs at the 60.3 point. So 60.3 through there, that's roughly where the median is going to occur. So we write that down at the end. Okay, it's a very difficult question. It's definitely worth spending some time over if you're not sure what I did there, but just make sure that you've got all your steps of working there written down. The final question, surprisingly only worth 4 marks, quite a lot of work for 4 marks, this last particular question. It's a circle geometry question. It will be probably covered in the latter months of your GCSE study, so if you haven't quite got here yet, that's not surprising. There is a set of steps that you would work through. I would always try and sketch this diagram first, so you've got to just figure out what the diagram looks like. I'm just going to switch out to a pencil because that's obviously dying. So here's my diagram. I've got a circle and it's got a tangent at the point -3,6. Let's just say that's there. And then you've got this line that goes from there to there, which is going to be the radius. And the tangent is always at right angles to that radius. Now, it'd be nice to know what the gradient of my radius would be, because if I can work out the gradient of my radius, I can work out the gradient of the tangent. And that's how you start these problems. To work out my gradient of my radius, I will do the up bit divided by the across bit. So the up bit is 6 and the across bit is 3. Okay, in this example, so 6 divided by 3 is going to be my gradient here, but of course it's going downhill, so it's going to be 6 divided by -3 as it were, so it's -2. So that's going to be the gradient of my radius here. So that's the gradient of my radius. My tangent radius will be -1 over that, negative reciprocal, so it's going to be -1 over -2, which is a half. That means the equation of my line, this particular line, will be y equals a half x plus c, where c is the intercept I've got to find. Now I've been given a point it goes through, -3,6, so I'm going to use that point. So put in 6, put in the half, put in the 3, put in the C, and again it's minus 3, sorry, and then you've got 6 equals minus 3 over 2 plus C to find out what my C point is going to be. And if you work out what that is, tapping it in, you get 15. So 15 is my intercept point. That's really quite straightforward, which means my equation by line is y equals half x plus, sorry, it's 15 over 2. I do apologise, 15 over 2. Now if I double everything, you get 2y equals x plus 15. That's the equation by line, just in a slightly different format. And again, to find out where it crosses the x-axis, because it's asking where it crosses the x-axis over here somewhere, where's it cross the x-axis? And you would put in your point, put in your values, and put in where y is 0, and you would get, in this case, x is minus 15. So x is minus 15 here. So, and you can see that from a diagram looks roughly okay. So the coordinate will be minus 15, 0, and that will get you your 4 marks. Okay, that's the end of this particular practice paper. I hope that was interesting. You might want to replay and go through certain bits of it again, because I do go quite quick, but I hope you found that interesting, and thank you very much for watching. Do join me again in the future when hopefully I'll be going through the rest of these papers in this series. Thank you very much. Goodbye.